All right, determine if the sequence shows converges at infinity. If so, find the sum. So we converge if the absolute value of the ratio is less than 1. All right, so let's see here. The ratio is going to be -2/4, which is -1/2, and I'm going to make sure that holds. Or the ratio is going to be 1/-2, which is also -1/2. The absolute value of -1/2 is definitely less than 1 because it's a half. So I know the series converges. All right, so the sum of an infinite number of things is this formula right here. The first term, which is 4, sitting pretty over 1 minus the ratio, which is a -1/2. I'm going to do a little magic with you here, okay? I'm going to do math by hand. 1 minus a -1/2 is 1 plus a half, which is 3/2. Dividing by a fraction is the multiplication of her reciprocal. 4 times 2 is 8. And I know, Milbrath just did something that, we shouldn't be able to do. But, let's just check this, see if Milbrath is right. Because, wow, I didn't know people could do math. It was 8/3. Huh. 4, we got sigma. Big whoop. Now, 4 is a little tricky because sigma's not starting at 4. So the first term here, this is actually going to be a sub 4 over 1 minus r. Not a sub 1. We're starting at 4. Now, it doesn't really matter on this problem because, honestly, well, you may not see it, but I'll go ahead and write two terms out so we can see the ratio. The fourth term would be 0.5 times 2 cubed. 2 cubed is 8, which is 4. The fifth term is 0.5 times 2 to the fourth, 2 to the fourth being 16, half that being 8. The ratio is 2. I knew that because it was in the form, and that's hard for some kids to see. But the ratio is 2, and the absolute value of 2 is definitely bigger than 1. The series diverges. But anyways, use this little knowledge that I just gave you on that one, because it's going to make a big deal on 5. Like when you do 5, the sum of infinity is going to be the third term over 1 minus r. It's not going to be the first term. It's going to be the third term. Anything else I had highlighted on that one? No. Anyways, you just keep working on 5. 7, if a sequence is geometric and the fourth term is 16 and the 10th term is a 256, write both the explicit and recursive rule. All right, so let's plug into the explicit form, and then let's do some algebra. So the fourth term is 16. 16 equals the first term times the ratio. Now 4 minus 1 is 3. The 10th term is a 256. The 256 equals the first term times r. Remember, it's 10. 10 minus 1 is 9. Now we're going to kind of go back to Algebra 1, do some substitution, do some solving. This guy would tell me that the first term is 16 over r cubed. Plug it in. That's probably where I'll lose you next year. tomorrow. 256 is 16 over r cubed times the r to the 9th that you already have. R to the 9th over r cubed is r to the 6th. So 256 equals 16 r to the 6th. And divide both sides by 16. If I was doing this on paper, I'd say 1 over 256 times 16, but 1 divided by 256, enter, divided by 16, enter, math, enter, enter. 4096. 4096 is r to the 6th. The opposite of 6 power is the 6th root. To do a 6th root in a TI-84, I raise it to the 1/6 power. It's going to be one of those little things that kills some of y'all. And I get a quarter. So r is 1 over 4. Now, I can take that quantity and I can put it right there. The first term is 16 divided by 1/4 cubed. That would be 16 over a 64th, which would be 64 times 16. I had it, lost it. Sorry, it's the end of the day. 16 divided by a 64th is 1,024. I have this piece and I have this piece. So the nth term, what a funny looking thing, the board didn't keep up with me, is 1,024 times a fourth to the n minus 1. Now let's do something we've been doing. Let's rewrite this two ways. Or it's 1,024, 1/4 to the n, sitting pretty over 1/4. Now let's take that 1,024. I know you remember this, but dividing by a fraction is multiplying by its reciprocal. So I should get 4,096 back. 4,096 times a quarter to the n. That was my teacher bell, so I'm working over. You're welcome, right? A pendulum swings through an initial arc of 24 inches. Each successive swing will be 95% that of the previous swing. When the pendulum finally stops, what is the total distance? So this is the first term. The next term would be 95% of that. This is my ratio, 0.95. I want to know the total distance swung. I'm finding the sum of infinity. It is the first term of 24 over 1 minus 0.95. Which is 24 over 0.05, which is a 20th. 24 times 20 is 480. Crazy how I did that. And that is in inches. It swings 480 inches or, 40 foot. Weird, huh? 11. Solve this thing. Oh, that's old. We're going to take away 8. 24 minus 8 is 16. We're just going to do easy stuff. I keep preaching do easy, but y'all keep doing you. See who's right, see who's wrong. Divide out the 4. 2 to the 2x minus 7 is 16. Log is bay. A log base 2, base exponent argument of 16 is 2x minus 7. Now, log base 2 of 16 actually has an answer of 4. I swear it does. Watch this. I'm going to do change of base. Log 16 over log 2. It's saying, hey, what power of 2 creates a 16? And it's 4. So 4 equals 2x minus 7. Add 7, you get 11. Divide by 2, 11 halves. Easy peasy lemon squeezy. 14 has been highlighted. If the sum from 1 to n of 2 times 3 to the n minus 1 equals 531,440, solve for n. Now I noticed that this is in the form a sub 1 times r to the n minus 1. All right, awesome. I also know that this sigma means sum, and the sum of n things for a geometric pattern is the first term times 1 minus the ratio to the n over 1 minus r. This is a rough little problem. That's the sum. The first term is 2, and the ratio is 3. Notice first term ratio. So 531,440 must equal the first term of 2 times 1 minus the ratio of 3 to the nth power, sitting pretty over 1 minus 3. Now we're going to do this old school by hand. 1 minus 3 is a negative 2. 2 over negative 2 would make that whole set of parentheses negative because it's negative 1. Let's go ahead and divide out the negativity. That'll also drop the need for the set of parentheses. Negative 531,440 equals 1 minus 3 to the n. Subtract 1. Negative 531,441 equals negative 3 to the n. Divide out the negativity again. 531,441 equals 3 to the n. Log is bay. Log base 3, argument 531,441 equals n. Change of base in a TI-84, the natural log of 531,441, sitting pretty over the natural log of 3, should be my answer, and it was 12. Last one, and I got a roll. Nah, Y'all got it. Ask it. I need to roll.